Hi everyone, welcome back to AI Incarnation. Today we are diving into Retrieval Augmented Generation or RAG, and I'll show you how to build a fully local RAG application using Streamlit for the UI and Ollama for running large language models entirely on your machine. Let's start by creating a file that is ragdemo.py, rag underscore demo.py. So this will be the file that we'll create. And in the data folder, I have already uploaded Windows What's New PDF. So this is the PDF that we are going to use for today's demo. The very first thing that we will need is PyPDFLoader, that is to read all the documents or PDFs that we want to process. We'll simply say from LangChain community import from LangChain community dot document loader import PyPDFLoader. Next is to split the text. For that we are simply using from LangChain community dot TextSplitter. We will use RecursiveCharacterTextSplitter. So what we are going to do is we will break the PDF into small chunks and then we will save it into the vector store. Next is the embeddings. For the embeddings, we are going to use OllamaEmbeddings, and to import it, we'll simply say from langchain underscore Ollama import OllamaEmbeddings. We will embed all the text that we are having using the Ollama embedding. Then we are going to save it into the vector store. And for the vector store, we are using Chroma. And to import it, we'll simply say from langchain underscore Chroma import Chroma. Okay, so the very first step is to load the PDF. And for that, we'll simply say docs is equals to PyPDFLoader. And we are having data folder. Inside that data folder, we are having Windows What's New PDF. We are going to load it. We'll simply say that file name dot load. So once we have loaded all the data, we need to split it into chunks. And for that, we'll simply say split the document into chunks. And for that, we'll simply say splitter is equals to RecursiveCharacterTextSplitter. And we need to pass the chunk size. This is the chunk size that we are going to break all the text. For example, we can set the chunk size to 1000. It will take the first 1000 characters, then split it, then next 1000 characters, then split it. And similarly, there is a chunk overlap, which will overlap these chunks so that we are having some context between these chunks. For this particular demo, I'll be setting the chunk size to 5K, and the chunk overlap, I'll set it to, let's say, 1500. And to get the chunks, we'll simply say chunks is equals to splitter.split documents, and we'll pass the docs. So we'll use the splitter and we will split the documents that we are having from this particular document. Next is embedding and storing it into ChromaDB. So for that, we'll simply say embed the chunks and store them in ChromaDB. We'll simply say embeddings is equals to OllamaEmbeddings, and we'll pass the model name. Model is equals to Llama 3.2 colon latest. So this is the model that I'm having on my local. Next is to store them in vector store. So we'll simply say vector store is equals to chroma dot from documents. We need to pass the chunks that we have generated, the chunks. We need to pass the embedding that we have created above, embeddings, and we need to say persistent directory is equals to ChromaDB. Okay, there is one error. I have to use langchain.TextSplitter instead of langchain community.TextSplitter. We'll define a function that will take the user query and fetch all the relevant documents with respect to that query. For that, we'll simply say retrieve the most relevant chunks from the vector store. For that, we'll simply say define retrieve. Inside this, we'll simply say query. That query will be of type string, and we will return a string itself as the output. We'll simply say results is equals to vector store.similarity search query, and we will take top 3 relevant documents. And to return this, we'll simply say return /n/n dot join doc dot page underscore content for document results, and we will simply return the list of documents that we have just got. Next is to generate the answer. So we will define a function, define generate underscore answer. For this, we'll simply say the query. It will be type string, and then we need context. That will be also of type string, and we will return the output as string. For that, we'll simply say response is equals to chat, and we need to import chat also. So we'll simply go to the top and from Ollama import chat. So this response will be based on the chat from Ollama, and we'll simply say model is equals to Llama 3.2 latest. In the message, we will pass role user. The content will be answer the questions based on the context provided, and this is the context. And next is user content will be the query. We'll simply return response of message of content. So this will return the output to the user. Next is we'll create the Streamlit app, import Streamlit as st, and we'll simply set the title for our page st.title Windows 11 RAG with Ollama and Chroma. We'll ask the user for a query, so we'll simply say user underscore query is equals to st.chat underscore input, and we'll simply say ask questions about Windows 11. Next is if user underscore query, that means user have asked a query, we'll simply say with st.spinner retrieving the relevant information. The context will be equals to retrieve the user query. We'll call the function retrieve and we'll pass the user query to get all the relevant documents. Next is we'll simply use the spinner to generate the answer, and in the answer we'll simply say generate answer, the user query and the context. At last we'll simply write the answer under double quotes. We'll simply say answer, that will be the answer. So we'll simply write this, and to run this we'll simply go to the terminal, the Streamlit space run space ragdemo.py. It will take some time to run because in the backend it is taking the document that we have passed, that is the Windows documentation, and it will break into chunks, then save them into the vector store. So that part is taking some time, so it might take a couple of minutes to run this. Okay, once completed, you will see an interface like this, Windows 11 RAG with Ollama and Chroma, and we can ask some questions here. So this is the document that we have just passed, and it has break down these into small chunks and save them into the vector store. And let's say we want to ask like, so let's ask what are the hardware requirements for Windows 11. So we'll simply say what are the hardware requirements for Windows 11. Windows 11. So what are the hardware requirements for Windows 11? We'll simply ask it and it's running. So it is fetching the most relevant top 3 documents, and after that it will pass them to the context. Then it will generate the answer. Okay, here we go. The hardware requirements for Windows 11 are these. Let's compare it side by side. So as you can see in the document, we are having the hardware requirements as this. Processor is 1 gigahertz or faster. So here we can see 1 gigahertz or faster. Next is memory. We are having 4 gigs or 4 GBs of RAM, which is fine. Storage is 64 GB, storage is 64 GB. Graphics card compatible, DirectX. So here you can see that it has given a pretty good answer. So it understood all the context of the document. Then it has responded us with the output. It got the top 3 relevant documents, took as them as the context, and as well as we have passed the user query to the chat model. Based on the context as well as the user query, it has generated this particular response, which is pretty good. I think it's almost same as the document that we are having. To further tune this, you can change the number of documents here, that is the k equals to 3. So we have used k number of documents as 3. You can change it to 5, 10, or how much documents you want to fetch. This is the most relevant documents that we are fetching from the vector store. You can try to adjust the size. You can also adjust the chunk size. For now, I have set the chunk size to 5000 and chunk overlap to 1500. You can try to reduce this based on the number of lines that you're having in your data. Or you can also choose a different model, for example, Gemma 3 or any of the latest models from Google. To extend this, you can add file uploads, support multiple document types, etc. That's how you will build a fully local RAG chatbot using LangChain, Ollama, Chroma, and Streamlit under 50 lines of code. If this helped, like, subscribe, and drop your comments below. I'll share all the relevant documents as well as the codes in the GitHub repository. If you face any issues, you can drop a comment. That's it for today, and I'll see you in the next video.